resources. So it was very hard to walk through to understand what was going on because there were very little resources. So a large part of what we did back then had to do with getting involved with the core members of the ecosystem. So getting onto the Discord community, getting onto the Telegram community, and holding a lot of discussions with different people that are well experienced. So if you had like a problem, you had to go into the Discord community to discuss with other people that have experienced that problem before, which was very difficult. And it saw a whole lot of developers get off-boarded the ecosystem because nobody could deal with that kind of pain. But recently, these days, there have been a lot of work on the resources and the documentation, and this particular doc is going to be highlighting those different ecosystem. So at any point, this call, I don't know, I haven't used this Telegram video call before, so I'm not entirely sure how it works for messaging. But at any point, I believe you should be able to send a message into the general channel if you have any questions, and I'll have Adewumi going through them if there's any messages. So this talk is going to be split into like, I think 5 different sections. I'm going to open the room for everybody that has questions to ask their questions so that we can attend to everything. I want to make sure everybody understands what we're going to be talking about in this particular call. So yeah, let's get started. Before we get started, a little bit of introduction into Polkadot. Polkadot itself is a very decentralized and very scalable layer 0 blockchain. If I open this link, just show you a little bit of important information about what Polkadot is. You can see it says Polkadot is the first layer 0 blockchain, and most of the other blockchains that we work around with, you think about the most popular blockchains like Bitcoin, Ethereum, Solana, Near, a large number of the community I've worked with Near in the past. So most of these blockchains are layer 1 blockchains. The whole idea of layer 0 blockchain did not exist as at the point when these blockchains were being created. So it only made sense for it to be layer 1. But when Polkadot came with a new approach, they decided to name it a layer 0 blockchain because the whole idea of Polkadot, according to what it is currently, according to the vision of Polkadot, Polkadot is trying to be what AWS is to the Web2 ecosystem. And that means anybody can come to Polkadot and deploy their decentralized applications. You can deploy your own blockchains, which ends up being a layer 1 blockchain on the same scale as blockchains like Ethereum, Solana, and all these other blockchains. So, and that is why they call themselves the first layer 0 blockchain that provides shared security. These are key words that we are secure interoperability to layer 1 blockchains. So the layer 1 blockchains, I'm going to go ahead and talk about them. The layer 1 blockchains on Polkadot are what you can actually deploy on top of the Polkadot ecosystem. Most other blockchains, they don't allow you to deploy blockchains on them. So you have to deploy a smart contract on other blockchains. But on Polkadot, you are allowed to deploy another blockchain. And the other blockchain that you deploy on Polkadot, it becomes a layer 1 blockchain. And these blockchains, they benefit from the shared security of the Polkadot blockchain. The Polkadot blockchain itself is a highly secure blockchain. It's very decentralized, and most of all, it is a very secure blockchain because it uses the nominated proof of stake, which is slightly different from the proof of stake that other blockchains like Ethereum or Solana use. Nominated proof of stake, that one is kind of a random approach to proof of staking. So any one of these L1s can become the validator at any point in time. But you can't really tell who is going to be the validator at any point because it's random. So it makes sure even if you have all the power on the blockchain, you can't be the validator forever because at a point in time, it's going to switch you out with somebody that has less power than you. Unlike other blockchains, whoever holds the majority of the stake pretty much dominates the blockchain for a very long time. And if someone has like 40% of the stake in the blockchain, then you can see that there's trouble coming. Even though proof of stake is very, very secure, anybody can remove their stake from whoever they kind of staked it upon, because the way proof of stake works is there are different validators, and then there are also different people that hold the tokens of the blockchain, and they are able to stake their tokens on each validator. So you can decide, okay, this validator, I see that he's very honest, I'm going to stake my token on him. So whatever token you stake, it also adds to the person's total stake in this ecosystem. And that gives that person more power to be able to make decisions in the blockchain. But on Polkadot, it doesn't work like that because it's randomized. So at any point in time, you definitely get switched out for a new validator. So which makes it very secure and very decentralized because there's no chance of anybody taking over the system at any point in time. And also, Polkadot has a secure interoperable network, which means all these layer 1 blockchains that are deployed on Polkadot, we call them parachains. As soon as they are deployed on Polkadot, they can start communicating with each other. It's just like a switch that you just turn on and off. And then any other blockchain can start communicating with you. They can send requests to you, and then you can handle those requests. It feels like you're talking through an API, kind of like the way web servers communicate, which is a very huge game changer that doesn't exist on many blockchains. A lot of blockchains have to use bridges to be able to communicate, or they have to deploy smart contracts on different chains to be able to communicate, but all of that doesn't exist on Polkadot. So you have a very interoperable network right from the first day that you deploy. And Polkadot is built by a very interesting team, a very functional team in the Web3 ecosystem called Parity Labs. This same Parity Labs is also responsible for building the technology that was used to develop Polkadot. So I'm sure many people will have heard about blockchain trilemma, like in a blockchain, is either you have 2 out of 3, you can't have all 3. Is either your blockchain is decentralized and secure and then not scalable, which is kind of what is happening to Ethereum, or it's scalable and secure, but it's not very decentralized. Like a lot of people claim that Solana is secure and scalable, but it's not decentralized. Or it is the same thing as Bitcoin, decentralized and secure, but you can't scale it. And this actually happens because of how blockchains are built. If your blockchain is decentralized and highly secure, a lot of people want to use it. And then as more users come upon your blockchain, it starts slowing down, gas fees start going up, your requests start taking a long time to complete, you start having to compete with other people in terms of which request gets accepted by the validators of the blockchain. But on Polkadot, all of this do not happen. Polkadot is decentralized, it is secure, and Polkadot is actually one of the main reasons why a lot of developers and tech on protocols are actually building on Polkadot, because it's very scalable. You can easily just upgrade your blockchain. You can, if it's slow, you can quickly request for more time. You can make it faster. You can, if it's too fast at a point, you can slow it down. You can do anything you want on the Polkadot ecosystem. Polkadot was developed using the Substrate SDK, which is something that we're going to be going into as this talk progresses. And a fun fact also, the Substrate SDK was also built by Parity Labs over here. So they built the Substrate SDK, they used it to develop Polkadot, and then they open source the SDK to anybody that wants to build their own blockchain to be able to use, which is a very fun thing to do. I mean, they don't keep the whole thing to themselves. Some of the resources where you can check out about Polkadot, I'm going to share some resources over here. Don't worry, these links will be posted into the Telegram channel right after the call, so you can go through them and just discuss about them and read through about them and understand what they say. Some of the reasons why you should actually build on Polkadot is because Polkadot is not just a blockchain that you just look at and just enjoy. It's something that you're supposed to come and deploy your blockchains on, deploy smart contracts, deploy anything that you want to build related to Web3. You can build it on Polkadot. And some of the reasons why you should be actually build on Polkadot is it has very great documentation and resources. And one of the documentations that I've shared, I've given you is this wiki. This Polkadot wiki actually a wiki things you need to know, cool information, different applications that are built on Polkadot, different dashboards that you can study analytics about Polkadot. It also contains crash courses, so you can learn about Polkadot, like general information about Polkadot, the basics of Polkadot. And it also teaches you how you can build on Polkadot. There's a whole bunch of tutorials on this particular section. So you see how it's split into different sections. There's development networks, client-side development, there's every single thing. This is actually your go-to resource for learning about anything that you want to do on Polkadot ecosystem. It also teaches you about how you can maintain your Polkadot network, your Polkadot-based blockchain after you've deployed it. It teaches you about that one as well. And one more thing, you can see you talk about Kusama here. Polkadot itself, it's the main, you can call it like the live version, but it also has a canary version, which is Kusama. Think about Kusama as better environment. It contains the different features and changes that are going to be on Polkadot in the future, but a lot of users can come to Kusama and test them out. So it's kind of like a DevNet environment. It's not testnet, because whatever you do on Kusama, you are using real tokens, you are using real money to build. It has like test environments where you can test things out, you can run around, you can use it fake money. Let me just call it fake money, because it's not money that if you lose, it's going to pain you. But if you lose money on Kusama, you might end up crying, depending on how much money you lose on Kusama, because it's actually using real money. And Kusama has its own token, which is different from Polkadot. Polkadot token uses dots, but Kusama uses the KSM token. So you need to be paying attention to that. But a lot of projects that end up becoming parachain, that end up deploying on Polkadot, they actually go through Kusama just to be able to test things out, because it's more volatile. It allows you to actually play around with things and experiment new features before they are deployed on Polkadot. And this particular point is one of the main reasons why Polkadot is very secure and very, very hard to hack and break into. It's not going to fail, because if it's going to fail, it will have been caught on Kusama, and then we can rework on that. We can improve the technology around it before deploying it to Polkadot. Polkadot also has like community support. There's a lot of support. If you join the Discord channel, which I'm gonna share towards the end of the call, if you join the Discord channel, you have like a lot of support. That is how I learned about Polkadot. I learned about Polkadot by jumping into the Discord server, asking a lot of questions, talking to people in there, and that is how I learned before it became way easy. You can go to the documentation and read about everything. And also, there's funding and grant opportunities on Polkadot. I'm not gonna lie, the Polkadot ecosystem they have a lot of grants. You can see there's a lot different available grants that you can submit to if you have like interesting projects, and they're going to fund your project. They funded a lot of projects. If you go through this section of the Polkadot ecosystem, you will see how Polkadot is actually like funding a lot of projects. And there's even other grants that are organized by parachains that are deployed on Polkadot. You can see a lot of them. There's the Polkadot treasury that you can demand for funds using a proposal, and then they can fund your project. There's different opportunities for grants and funding. There's also hackathon opportunities. Honestly, I used to do a lot of hackathons, and a lot of my hackathons were in the Polkadot ecosystem. One of the reasons was because some of the reasons that I mentioned, because there wasn't a lot of great documentation back then. So many people will not want to build on Polkadot. But that was a huge opportunity for hackathon developers, because you could build your project and then you have less competition. I mean, less competition is not always good, but in this sense, I mean, if you build a project where a lot of people are not building, you are very much more guaranteed to win some of those projects on your hackathon chance. You have a lot more chances to win as opposed to participating against 1,000 people or 2,000 people. Although I wouldn't guarantee that the number of participants will still be low, because now there's a lot of resources, and hackathon participants have actually been getting onboarded a lot more on Polkadot. But there's also a lot of open source projects on Polkadot ecosystem. Honestly, all the projects on Polkadot, like 90% of them are open source. The Polkadot SDK itself, which houses the Substrate SDK, it houses the code base of Polkadot, Kusama, and some test environments. It's also open source. And the cool thing about it is Polkadot has a fellowship program, which is, they have a fellowship program that if you contribute to the open source projects a lot, you can apply to these fellowships, and then they can start paying you salary at the end per month, which is very cool. All you're doing is open source contribution, but you actually get paid for doing that. Depending on how much contributions you make, you actually get an increase in your salary. So it's a very cool process. One last point on theoretical aspects of Polkadot are some of the things that you can build on Polkadot. So you can build blockchains on Polkadot, which I've spoken about. The blockchains you build on Polkadot, they become layer 1 blockchains, and we call them parachains because, yeah, I mean, the parachains, they run parallel to each other, kind of. So that helps you to remember the word itself. There's a lot of parachain slots available on Polkadot. If you go through the Polkadot architecture, which is housed somewhere on this documentation, the architecture is right here. You can see how the parachains benefit from Polkadot if you run through this thing. So the relay chain is right here, but it has these different slots. I'm looking for a certain diagram right here, which shows the different slot. I mean, this is the relay chain. You can see how the parachains are right here. This is not the exact one that I'm looking for, honestly, but the point is the relay chain, it houses a lot of different slots. It would be nice with an image, but let me give it an explanation of it. It houses different slots, and on each of these slots, we call them cores. You can deploy your parachain on each of them, and then you have access to the Polkadot ecosystem. It's kind of like, think about a computer, your laptop. It has different CPUs. You might have like a CPU can be like 4 cores or 2 cores. Each core is where every computation that you want to do on your computer happens. So that's kind of like what the idea that the Polkadot ecosystem brings about to the parachains. And currently, I think there's like 100 cores that are available for parachains to actually deploy upon. So that's one cool thing that you can build on Polkadot. You can also build smart contracts on Polkadot, but this is a little bit tricky because Polkadot itself does not allow you to build smart contracts on the blockchain. So what you do is you build a parachain, or you look for a parachain that allows deployment of smart contracts. We're going to get into that. We're going to get into a lot more explanation into how smart contracts can be built on Polkadot. But in summary, we just know that you can deploy smart contracts on Polkadot, but you do that through a parachain, which is a blockchain that is deployed on Polkadot. Also, you can also build full stack applications on Polkadot. So full stack applications mean an application that's communicating with a smart contract. So it has like a front end, and it also has a back end if you want to have a back end. So these are some of the 3 things that you can build on Polkadot ecosystem, pretty much on any blockchain actually, except from blockchains, because you can't build a blockchain on another blockchain. So that's one aspect where Polkadot is very different. Before we go into the next section, I'd like to know if there's any questions, If there's any questions, I'm going to take some questions on the theoretical part of Polkadot before we go into the next section.
Yeah.
And you can easily unmute if you want to ask a question, actually. I think chatting might be a little bit of a challenge, but you can unmute and ask any question that you want to ask before we go into the next section. But if there's no question, I guess that means I'm doing a very good job of presenting this topic. So I'm going to go into the next section. The next section just talks about...
Sorry.
okay.
I think someone is trying to send a message to the group. I think they have a question.
Oh, okay, awesome. So what's the cost implication for running a minimal test on Polkadot? I'm not sure what you mean by minimal test, but if what you mean is running a test blockchain on Polkadot, I'm still going to talk about like the blockchain aspect of things, but if you want to run like a test application on Polkadot, it's pretty much free. You don't, as long as it's not for any tokens, there's the Polkadot faucet where you can get free dot tokens or free tokens for any layer 1 blockchain that you want to build on. So running a test application on Polkadot is pretty much free. I mean, the only thing that you might want to pay for is maybe if you want to pay for a course to learn about the technology. But running the test application on Polkadot is pretty much free. That's a very good question. I mean, a very interesting question. As it should be on any blockchain, if you're trying to deploy on the test environment, actually, it's supposed to be free because it's test environments. You're not supposed to be using actual money to deploy on this blockchain. So which is a good thing on Polkadot ecosystem. It's going to be free. So some of the prerequisites that you need to know before we actually start learning about Polkadot, before you want to talk about it, you need to be familiar with the Rust programming language, because a large part of what we do, Polkadot SDK is built in Rust. Substrate SDK is built in Rust. Deploying blockchains using writing substrate runtime or substrate node uses Rust as well. Even smart contracts, there's a catch to that, but the most popular smart contract library on Polkadot uses Rust as well. And is there a question? Also, you want to be familiar with TypeScript and JavaScript, because if you want to build the front-end applications, this is what you're going to be using: TypeScript, JavaScript. You also need to be familiar with scripting, maybe bash scripting. At least you need to be able to work your way around the terminal. You need to be able to view terminal commands and understand what they're doing. You need to be familiar with Git or Bash or any other terminal solution that you have. And also, basic blockchain concepts is a given. And on the Polkadot wiki right here, it houses a lot of different information about accounts, transactions, what they mean, and these are very valid things that you need to be able to relate to if you want to be able to build on Polkadot. Pretty much on any blockchain, actually, you need to be able to understand the basics of the blockchain, how blockchains work. So we're going to be jumping into the Substrate SDK. So this is, before we go into the I'm going to take some questions on this place as well. But if there's no question, we're going to be talking about the Substrate SDK development tools. So call them parachain. Oh, okay, go on, question.
The question is that you made mention of building like Polkadot being layer 0 and other blockchains build on it. Like for blockchains like Ethereum now, they build on something like Polkadot or something. I want to get that part clear. And if not, or what are other blockchains? You can give an example of blockchains that build on L0, layer 0. Thank you.
Oh, okay, that's a very good question. A very, very good question, honestly. So Polkadot, like I said, is a layer 0 blockchain, and Ethereum is a layer 1 blockchain, right? Ethereum is an EVM blockchain that is built from scratch. So like they fork Bitcoin, the code base of Bitcoin, they forked it and then made some editing to it, like change some values, change a lot of things around, and that gave us Ethereum. Polkadot itself uses Substrate SDK, and then it builds itself up as a layer 0. So some of the blockchains that have been built on Polkadot, frankly, you can build any type of blockchain on Polkadot. Some of the blockchains that have been built on Polkadot include, and you can see a lot of them on so if you go into here, sorry, not here, Polkadot.Js, I'm going to show you applications that are on if you go into different blockchains that have been built on Polkadot itself. 1 second, just for this to load. Some of them use EVM, which is very similar to what Ethereum is. An example is the Moonbeam blockchain. Moonbeam is a layer 1 blockchain that was built using the Substrate SDK as well, and then it is deployed on Polkadot as a layer 1, making it a parachain on Polkadot. And on Moonbeam, it actually works pretty much like Ethereum. It's an EVM blockchain. You can write Solidity smart contracts on Moonbeam, and you can also interoperate with all the other blockchains that are on Polkadot. Another example of a blockchain, sorry, this is definitely not where I want to come to. Let me, Polkadot.Js apps, Polkadot parachains. Yeah, parachains right here. This is where I want to come to. Polkadot.com/parachains. There's a list for all the parachains that have been deployed on here. 1 second. A lot of working around has happened on here. 1 second. Polkadot apps. Here. These are some apps that are available on Polkadot. DeFi. So these are just applications. And funny part is a lot of these applications, you can see they are like dApps. They are written. Some of them are parachains, like Bifrost is a parachain on Polkadot. Akala is a parachain on Polkadot, which allows you to build DeFi applications. This is the Akala ecosystem. It's a parachain that is deployed on Polkadot. Polymer, Stellar Swap, a lot of these are Polkadot parachains. There's also gaming parachains. There's on Ethereum. They are all fighting for block space. They are all fighting for Ethereum resources. And this is one of the reasons why Ethereum becomes slow. And not just Ethereum, actually. I'm just using Ethereum because it's actually the most popular blockchain. But even on other blockchains like Solana, like Near Protocol, they all have the same issues. So you build everything you want to build on them. But on Polkadot, each layer 1 blockchain that you build, they actually cater for different things. So your social network is not affecting your DeFi application. So normally, DeFi is going to take a lot more things because people like spending money, they like making money, investments. You might need a lot more resources for that. We don't want to take from that resources and give to social networks. We don't want to take from that resources and give to healthcare networks. We don't want to give it to decentralized identity. So each of them have their own resources, and this makes them fast. They can allocate the resources the way they want. They can demand for more resources from Polkadot's blockchain, and this is the reason why Polkadot is not slow. It's never going to be slow, honestly, because everybody is not. They can, and the cool thing about them is the healthcare application, or let me use the digital identity application like Subtxt Protocol. It can actually ask for information from. Okay, let me put it this way. If you're building a social network like Subsocial, which is like a social application where you're chatting, that Subsocial can actually ask Subtxt Protocol, which is a digital identity network, for information about a particular user. So it's interoperable in that regard. It's not getting slowed down. All it needs to do is just send a message to Subsquid like, oh, this guy, tell me information about this guy, and then it returns the information to Subsocial, and that one continues. So it's not going to be slow. It's just asking for information, and it doesn't affect its own resources. So this is one reason. This is one of the important things. And also, from the question that I think Bidemi asked, you would like to know how to become a blockchain dev. We're going to go into that actually, but by following all these resources, by the end of this call, let me know if you still don't have an idea how to become a blockchain dev on the Polkadot ecosystem. So that's exactly what this particular call is all about. I think that answers your question, Habib.
Thank you.
Yeah, nice. So we're going to go into the next phase of this, which is Substrate SDK. Substrate SDK, this is one of the tools that you can use to build on the Polkadot ecosystem. And this Substrate SDK is actually your key to building blockchains on Polkadot. The Substrate SDK is a Rust-based tool that allows you to write logic for your blockchain. We're going to go into the slide documentation. I have a bunch of things on my iPad right here. 1 second. Just need to, I have a bunch of resources for the Substrate documentation, and I'm just going to copy one of them onto this place. So the Polkadot SDK, the Polkadot SDK, not DK, this Polkadot SDK is one big house that hosts the code base for Substrate. And you can see a lot of it is written in Rust. You can see your cargo.toml and all of that. This is the code base that is used to build the Substrate SDK. And the documentation can be found on docs.substrate.io. It's a lot of information. It's actually like a wiki for Substrate. Everything that you need to know about Substrate is hosted on this particular page right here. So to be able to build in Substrate, you need to understand Rust. You need to know how Rust works. You need to have understanding about Rust. So the Substrate SDK, this is the Substrate at a glance. What is Substrate? It's just an SDK that uses Rust-based libraries and tools to enable you to build application-specific blockchains from modular and extensible components. This is a very cool thing because previously, if you wanted to build a blockchain, like the way a lot of blockchains have been built, you have to fork an existing blockchain. So the Ethereum blockchain is a fork of the Bitcoin blockchain. So you fork the repository for Bitcoin and then you change some logic. You need to know exactly how it works and all of that. Then you do a lot of things on a protocol level. It's a very difficult task. I'm not going to lie to you. It's a very difficult task. And it's something that I wouldn't presume that one person can sit down and actually write it. The Ethereum blockchain was written by a large number of people. And funny enough, one of the founders of Ethereum is actually the person that actually founded this Polkadot. If you think about, there's a lot of founders of Polkadot. There's founders, there's co-founders and all of that. But frankly, a lot of it can be attributed to one person because he came up with the idea for all of that, for Polkadot, for building like Polkadot itself. And then they wrote this Substrate SDK, which is the first thing that you have to write first. Then after writing the Substrate SDK, they use that SDK to build the Polkadot ecosystem. So one very important aspect where Substrate differs from the previous ways of building blockchain is that it is modular and extensible. It's kind of like building, I don't know if anybody is familiar with Lego bricks, like all these games that you play when we were children, where you put different bricks together to build a house. You don't need to know how to build a house. You just need to find where the tire is or where the room is, put it together, put another room on top of it and all of that. That is very similar to how Substrate works. All you need to do is there's a lot of palette, a lot of libraries, a lot of crates here. Let me call them crates, because that is what they are called in Rust. There's a lot of crates that you can use to actually just compose a blockchain on your own end. So you just have to say, oh, this is what I need. Take that part and put it in your runtime. Take this part and put it in your runtime. And in one of our next classes, we're going to be talking about the Substrate SDK itself. We're going to be going in details about it. But if you want to go in details about Substrate right now, it's actually a very deep thing. But it suffices to know that there's actually three key components of the Substrate SDK, which is the Substrate node itself. The node composes of a core client with outer node services to handle network and blockchain activity. So this allows you to handle things like peer-to-peer communication, especially, and any other thing that your blockchain will need to be able to do with outside things. And also there's a runtime with the business logic for state transitions and the current state of the blockchain. We all know that a blockchain is just a database. It's just a database, technically. A database that anybody can update from any region, wherever they are. And it has some complicated cryptographic techniques to be able to know which updates should take place, which update should be the right one, or which one should be discarded. That is simply what the blockchain is. So the Substrate allows you a Substrate node. And then there's also Frame. Frame is not to be confused with mirrors or something, but Frame simply means framework I think the real meaning of frame is the framework for runtime aggregation of modularized entities. So it's simply the same word. If you go through this place, you still see the full meaning for frame. I just wanted to make sure I get the words right, but it simply means framework for runtime of aggregated modularized. This part, take this part, and then complete into a module, and it gives you your blockchain, just like magic. And then there's also the custom runtime, which is pretty much part of the runtime node. So those are the three main aspects of Substrate SDK. So for you to be able to build a Substrate application, you need to know about the Substrate node template, which is something that I'm going to put right here. The Substrate node template is your beginning for building Polkadot applications, or building Substrate applications. Let me just copy the link and paste it here. And I'm going to share all these resources in the Telegram channel. But you can see there's a whole bunch of templates. All these templates, they are actually relevant to the Substrate node template. If you want to use any one of them, you can just run this command on your local environment. If you have Rust installed, you're going to be able to do this. If you have Git installed, actually, you can clone this repository, and then it gives you like a bare bone boilerplate for starting up a what's it called? A substrate application. This is the minimal boilerplate. You can see it has a node, the palette, and the runtime. This is pretty much all you need to be able to build a blockchain in Rust on Polkadot ecosystem. And one funny part about Substrate, one very interesting fact about Substrate is, even though Substrate was built for the Polkadot ecosystem, you don't have to use it to build an application for Polkadot. So one very interesting runtime that I know about is this Madara sequencer. Madara is a sequencer for Stacknet blockchain, and it is actually built using Substrate. Like a very, very interesting application. I was actually surprised to find out like a lot of applications are using this, and this is currently read-only for now, but it is built using Substrate. So you don't have to use Substrate to build on Polkadot. The only advantage you get for using Substrate to build on Polkadot is the fact that you get to benefit a lot from Polkadot's security, interoperability. But if you don't care about all of that, you can use Substrate to build your own blockchain that works just like Ethereum, and it has nothing to do with Polkadot. So which is a very fun thing that you can do with Polkadot. You can see by using the Substrate framework, Madara amplifies the capabilities of Cairo virtual machine, leading to provable, secure, and flexible programs. So this is a very key thing. And there's also some other blockchains that have been built using Substrate, and you don't have to just build on Polkadot, which is the main thing that you need to know. I said a little bit about Frame libraries. Frame is framework for runtime aggregated modularized entities, and it's the modular component for Substrate runtimes. There's a whole bunch of frame palettes that you can install into your runtime. So if you see this Subsquid documentation, it also talks about frame palettes. These palettes, I don't know, palettes just sound like, I don't know, if you talk about medicine or pills or something, just a tiny pill, like a capsule, that if you ingest it, it will go ahead and do a lot more work for your body and all those kinds of things. So that is why, I think that's why they call it pallets actually. So pallets are your entry into building blockchains, and there's different types of pallets. There's the pallet aura, which can be used for consensus. So if you don't want to use proof of stake in your blockchain, you don't have to build your own proof of stake application. No, Substrate already has all these libraries. All you need to do is just install this palette aura into your Substrate runtime, and then you have the consensus engine already running. Babe is also another consensus application. You can see there's a lot of them. Balances allows you to handle accounts and balances. You don't need to handle the transactions or balancing or all those things on the Polkadot on Substrate SDK. All you need to do is just install these palette balances, and then your blockchain can work just like magic. There's a lot of them. There's also lottery. If you wanted to build a lottery application that allows network participants to purchase tickets into your application, into your blockchain, you don't need to write that logic by yourself. You can implement this palette lottery. There's also Nix, which is for naming, on-chain naming, like a domain name service. So if you want to assign names to your wallet addresses, you don't need to build that logic by yourself. You just install this Nix palette and your blockchain is up and ready. Pretty much, you can build a blockchain without writing almost nothing. All you need to do is just look for the right palette, add it to your runtime, and it's going to be working just like that. And that if you go through documentation for, I want to go through one of them. Let me go through this Nix palette. You open it, you can see that it's just a, oh gosh, what just happened? I think the links might be broken, but this is the palette Nix. This is the palette Nix for building. You see, you can just, it's just like a library. If you're familiar with JavaScript, it's just as if you want to install React Router into your React application. So what React Router does is, can you guys hear me? Did I hear your question? Sorry, I'm just going to mute you. So, oh shit. I wanted to mute you for the call, but yeah, sorry about that. So what this does, I was giving an example, illustration of React Router with the way it relates to React, because I used to do a lot of front end in the past. So that's a very good example that I feel like a lot of people can relate to. But if you can't relate to that, I hope this solution will help you. So React Router is a library that helps you to handle routing in your React applications. So instead of having to write out the routes by yourself and handle, click on this, go here, click on this, go here, all you need to do is just install React Router, do some little configurations, and you don't need to worry about it anymore. You just have the routes working automatically. All you need to do is just add new routes and all of that. That is exactly what the palettes are to a Substrate SDK. If you want to have a domain name service implementation on your Substrate chain, you just implement palette nicks. And this frame is actually a very big entry point to a Polkadot SDK, to the Polkadot world actually, because a lot of these palettes are open source. So instead of building a blockchain, because to be honest, Substrate SDK, it makes building blockchains very easy, like very, very easy. I'll say like 1000% easier, but it doesn't mean it's still easy because it's not a one-person job to build a blockchain. There's a lot of moving parts involved. You will eventually need to have a team, but you can build different palettes and make them open source for the Polkadot ecosystem to be able to use. And this gives you a lot of, because now you do something for the ecosystem. Different palettes exist. You can even create your own custom palette and push it to the ecosystem for anybody to be able to use in their blockchain, which is a very, very cool implementation for this particular world that we're in, the Substrate world. So two things: the Substrate node template is like a boilerplate application that allows you to be able to start building a blockchain application, and you can choose from a list of different templates which can be found on this Polkadot SDK repository here. This is an SDK for building a parachain. You can just clone this one, and then you have the boilerplate for a parachain. All you need to do is just change up the palettes that you need inside the runtime here. If you check this cargo.toml, you see that is easily what this guy does. It has palette aura for consensus, palette balances for handling balance, palette timestamp for taking note of the timestamps, palette XCM, which is a very, very important thing in Polkadot, because XCM is the machine that allows Polkadot applications to communicate with each other. So it's like the interoperability backbone for Polkadot. If you want to have interoperability enabled for your blockchain, you don't really need to do it manually. You don't need to do it manually. All you need to do is implement this palette XCM, and then you have XCM already working. So very, very interesting thing. Very, very easy to develop with Polkadot, the Substrate SDK. Some tools that you also need to get familiar with if you want to build with Polkadot, and these are new tools actually that are coming up and making the job a little bit easier. One of my favorites is Pop CLI, which is something that I actually have some very good history with. So the Pop CLI, we call it Play on Polkadot. Is a very cool name. I actually love that name so much. Pop, Play on Polkadot. So that is what it is. It's a CLI that exposes a lot of command line interface, command line tools, command line things that you can use to get started with Substrate. You can use it to install a Substrate application. You can use it to set up different Substrate templates. You can use it to build your Substrate library. You can use it to do anything that you want to do on Substrate. Let me just open the link for you right here. Learn on Pop, like the Play on Polkadot application. It allows you to build app chains very easily. Set up your development environment. If you want to get started with this one, all you need to do is install the Pop. You need to have Rust installed, obviously, because this is a Rust crate. So once you have Rust installed, you can just do Pop install. It installs the Pop CLI for you, and then you can create a new parachain. There's different templates. There's the assets parachain template. This will just give you a way to a parachain template that already has assets logic already implemented. There's also the contracts parachain. So this contracts parachain is a very, very key thing, and it's also a palette, which you can see right here. Palette contract. This palette contract is what you need to implement if you want your Substrate chain to be able to allow smart contracts. So, I mentioned earlier that Polkadot itself does not directly allow you to deploy smart contracts on it. and this is just for security purpose. But if you deploy a parachain or a layer 1 blockchain or a substrate blockchain, for now I'll be referring to them as an app chain. If you deploy an app chain that has these pallet contracts in it, then you'll be able to build smart contracts on that app chain. And that simply means that you're able to build smart contracts on a Polkadot ecosystem. One very cool thing that POP also allows, because if you deploy on an L1 like Astar, then that means you have to be using the Astar token to be able to interact with your smart contracts, because it's using that L1's network. But POP as well, they have a POP node that uses the native Polkadot token, which is DOT. And the hope of this is it's going to allow a lot more people to get familiar with the DOT token and give it extra usability. So it gives it a lot more usage. Now you can use POP to deploy smart contracts. You can use DOT to deploy smart contracts, to interact with your smart contract, to pay for tokens. And one cool thing about building with Substrate, you can build smart contract that it is totally free. You don't need to pay gas fee. It depends on how you set up the logic of your parachain, of your Substrate SDK. So it gives you that much flexibility, which means you can have a smart contract and you are just running it. You are not paying gas fee. Although I wouldn't advise that, because that means anybody can just run logic that can run forever on your chain and just slow down your application. Which means find a way to make sure that kind of thing does not happen. But it's all up to you. You can do your blockchain anyhow you want it. Polkadot does not care how you do it. And that means you can also do your smart contract anyhow you want it. Nobody cares about that one. All that matters is it is secure and it works very well. So this is a very interesting tool for the Polkadot ecosystem. POP, you need to get familiar with it if you want to be able to build app chain or parachains. It makes the process very, very easy, very, very seamless, much more seamless. And there's also ZombieNet. Yeah, this is also one cool name. Polkadot has a lot of very cool names, honestly. ZombieNet, the ZombieNet is a testing tool for Polkadot. So it allows you to spin up different nodes as you want. So why is it necessary to spin up nodes when you are building something? So in case you want to test, you are writing some logic, you need to test that logic to make sure that it's working very well. You don't have to go ahead and run the node for that blockchain, which is something that can take, like, if you've ever run a node before, like a Bitcoin node or an Ethereum node, you know that it's going to take you nothing less than at least 4 or 5 hours to be able to run the node to a good extent. Sorry, I'm copying something, but it's not here. If you've ever tried to interact with a Bitcoin node or like an Ethereum node or something, you will know that it takes a very long time to get this node up and running. And that is why ZombieNet is very important, because it allows you to spawn up a network as fast as possible. This network that you spawn up is temporary, obviously, but you can use it to test, just to make sure that your substrate chain that you just deployed is actually working fine. And that is the usefulness of ZombieNet. You can also use it to test, and pretty much almost all the parachains in the ecosystem, they use ZombieNet right now. There's a list of different parachains that are using ZombieNet somewhere on this documentation page. Somewhere on this documentation page, you can find a list of projects here that are using ZombieNet. This is just a few of them that are using ZombieNet to test their blockchains and make sure everything is working fine. So these are some of the tools that you need to get familiar with if you intend to build a Substrate SDK, and some of the things that you can build using Substrates. Some of the things that you can build individual palettes. I spoke about these ones. So you can build your individual palettes and open source it to the ecosystem. And that means anybody that's building a blockchain using that palette, they are using your tool, which is very cool. And you can even build you can build it and maybe you can monetize it if you want it in some ways. You can do anything you want with your palette as long as you build it. But it's not really recommended to monetize it, because anybody else can just build it and make it free anyway, because the process is not hard. So you can also build custom runtime. and you can build parachains. So important differences between custom runtime and parachains, because at the end of the day, a custom runtime is also a blockchain. The only difference is it's not deployed on Polkadot. So you can build any blockchain that you want and make it a custom runtime using Subtxt SDK. And this custom runtime can do anything that you want it to do, pretty much anything. And that is probably your entry point before you can start building a parachain and all of that. The logic is pretty much the same thing. The only differences are the tools. If you want to build a parachain, then that means your blockchain, your Subsquid SDK needs to implement the pallet parachain. There's a pallet parachain that you have to implement, and that gives you access to almost everything that a parachain needs to have. So yeah, setting up a substrate tool, it just involves installing Rust and then Rust up. You can have pop CLI and all of that. I don't know if there's any question. If you have any question, I'm going to be taking question on the process for building substrates. Just going to take a small breather and wait for any questions that are available. Yeah, the documentation actually. Let me, no, that's a good idea. Let me draw some of the documentation right here. Truth is, let me copy the one for substrate. These are some. These are some documentation for the Polkadot wiki. You can follow along. There's also a bunch of them around here. For the substrate SDKs, let me put the documentation for the substrate node template right here. For some reasons, I'm trying to copy it from my iPad, but yeah, copy this time around. So yeah, this is your guide to substrate templates. Then for the pop CLI, you can come up to the documentation around here. For the pop CLI, very interesting documentation. Do you have anybody with any questions, any concerns, anything that's not clear so far? As usual, if there's no question, I mean, that just means that I'm doing a good job of explaining all these things. So I'm just going to go on to the next thing. I feel like we're almost out of time, but you guys just need to bear with me. Guys for like 10-15 minutes, but the remaining part of this talk wouldn't take more than 15 minutes because we're pretty much wrapped up. The substrate SDK is actually the most complicated part for building a Polkadot ecosystem, and it's not really the recommended approach. It's not the recommended starting point for new users. So the recommended starting points for new users would be Ink, which is smart contracts. Pretty much a smart contract is different from a blockchain, right? Because you don't need to worry about a lot of overhead. And I'm going to open the Ink dev documentation. So use Ink documentation. Yeah, why Rust for smart contract? It gives you a lot of reasons why you should pick Rust, but a lot of them is, you can read a lot about them in here. Smart contracts in Polkadot, it talks about smart contracts in Polkadot on here. I have a very interesting tool right here that you can use. It talks about why you should build a Polkadot. So a parachain state transition function doesn't get further validated. But if you check for smart contracts, on the other hand, the deploy smart contract code is not really trusted. So anyone building their parachain, they have to make sure that whatever is coming, they are validating it. And then you can upload a smart contract without requiring permission. It's permissionless. The deployment doesn't need to take permission from anybody. So which is a very cool thing about smart contracts on Polkadot. I'm going to share this resource as well for how to learn about Polkadot smart contracts. So if you want to get started with Polkadot smart contract, but the Polkadot smart contract, as I mentioned, you can deploy it on any blockchain that has the pallet contract implemented in it. So as long as it has that, then you can build the smart contract using Rust. And the framework is called Ink. Ink itself is a Rust-based EDSL. which is an extended domain-specific language that allows you to build smart contracts. So pretty much when you're writing ink, what you're writing is Rust. You need to understand Rust. And one cool fact about smart contracts on Polkadot, I already mentioned that earlier. I'm going to say it again. You don't have to use Rust to build smart contracts on Polkadot. There's also a bunch of other tools. There's Ask Library, which is currently, I think it's currently not being worked on anymore. This one uses assembly script. Assembly script is a variation of JavaScript or TypeScript that you can use to build smart contracts. So if you don't know Rust, you can use Ask, and then you can build smart contracts on Polkadot. You can also build smart contracts on Polkadot using Solidity. Very, very cool thing. If you want to use Solidity, there's this Solang library. The Solang library, it also works with Solana actually. So it's the same thing. You can use it to build smart contracts on Solana using Solidity, and you can also use it to build smart contracts on Polkadot using Solidity. The cool thing about it, the summary of it is you can use any library that can compile to WebAssembly module to build smart contracts on Polkadot ecosystem. So the WebAssembly module is the key glue to building smart contracts on Polkadot ecosystem, and any library can be used to build this kind of thing. Some of the tools that you can use on Ink as well. You can also use the Pop CLI actually. So Pop CLI is not just for app chains, but it's also useful for smart contracts. It's also a tool that you can use to build smart contracts library. I'm going to share the resource right here as well, so you can go through it. You can go through this one. You can use Learn on Pop for smart contracts. It's also a tool. It's kind of like, if you're familiar with Solidity very well, Pop is like hard hat. So, you know, if you install hard hat, then it has everything that you need to be able to build a Solidity smart contract. That is the relation that Pop has with hard hat. So you install Pop, and then it's like a framework that gives you access to different commands that you can use to test your Ink smart contract. You can deploy it, you can interact with it, you can even set up a node very quickly, because behind the hood, Pop also uses ZombieNet to be able to set up some nodes that you can use to test your smart contract. And if you deploy on Pop, on the Pop node, you can actually deploy using DOT tokens or the Passio testnet token. So if you're building on the test environment, you can get Pass token, which is a testnet for Polkadot. It's the Passio relay chain, so which is what the Pop node. It's actually built by the Rogue team themselves, the team that built this Pop CLI and the Pop tools. So that is that about Ink smart contracts. One other very important point that I need to actually mention about Ink development is the PSP, which is the Polkadot smart contract proposals. These are similar to ERC proposals on Ethereum. I'm trying to get the link. I have a link right here on my iPad. So if you go to this link right here, you can see that there's a list of Polkadot smart contract proposals, and these guys, they allow you to build things like fungible tokens and non-fungible tokens. You can build your NFTs, you can build tokens like ERC20 tokens using these PSP proposals, and some of the key implementations, because just like how ERC proposals exist, but then the implementations are actually being built by OpenZeppelin. We have the PSP proposals that are actually being built by this team right here. If you go through the cardinal cryptography, two major teams are actually involved in building the PSP proposals, which is the cardinal cryptography team. If you go through, you see the PSP22 tokens. This is relevant for building tokens, fungible tokens, and this is just for building non-fungible tokens. There's also the PSP37 proposals. It's not on here, but it's been built by the, let me share this link right here. This is for cardinal cryptography, but there's also the OpenBrush team, that is working a lot more extensively on building these PSP proposals. OpenBrush, a very cool name as well, OpenBrush. You can see they have PSP37, which is for the equivalent of ERC1155, which allows you to build multiple NFT tokens that have they have tightly similar to each other. So it's non-fungible, but it's kind of fungible in a sense as well. So this is PSP34 for NFTs. This is PSP22 for normal tokens. I'm going to share this link with you guys as well. So you have a good documentation guide for all of them right here. And one thing that I'll actually request from the organizer, Adewumi, is if you have time, you can just compile this list somewhere so that, or maybe you can just bookmark them for the community so anybody can access them, so you don't have to be scrolling around. Maybe you just compile them into a Google Doc and then pin them somewhere at the top here. That would be very helpful for anybody to be able to use. So yeah,
all right. Okay.
Yeah, do we have any questions on Ink smart contracts before we go into the last part, which is for front-end development and back-end development on Polkadot ecosystem? I'm going to take some questions if you have any questions. Just by the way, this call is being recorded, right?
Yeah, sure. It's being recorded.
Yeah.
Sure.
Do we have any questions? If you have any questions, I'm going to be taking some questions. I'm just going to leave the floor open. If you think of any question, you can actually just interrupt me, because this last section is actually going to be fun. So you can just interrupt me and then I'll answer the questions right there. So the last part about this particular thing is the front-end and back-end integrations approach to Polkadot development. So we have a number of tools that you can use to actually build your front-end application. So let's say you've deployed your Substrate parachain. How do you bring up all that functionality to somebody that doesn't care about it? You deployed your Ink smart contract. How do you build a decentralized application out of that anybody can use and interact with? And that is what this section is all about. The key most important tool for interacting with Substrate applications or smart contract is this Polkadot.Js. The Polkadot.Js tool, which is right here. This is the documentation for it right here. It houses the Polkadot API library that is built using TypeScript. So this is where anybody, if you're coming from a Web 2 background, this is your entry point into Polkadot ecosystem. This works just like, let me call it Ethers or Web3.js library that is useful a lot in the Ethereum ecosystem. So this Polkadot.js library is what you need to install into your React application or your Next.js application or Node.js application. Anything that has a package or JSON, you can add this Polkadot API in there, and then you can start interacting with your smart contract. There's a lot of documentation in here that can help you to get started with this. There's a lot of documentation right here that can help you to get started with this front end. This one allows you to interact with your substrate-based parachain. If you see, it has like the key part of it is this metadata that works pretty much like an API. And one thing about Polkadot, the one thing that makes this Polkadot.js different from the way APIs work in Ethereum or other blockchains is in those fields, you have to download the API, have it on your front end and all of that. But for Polkadot ecosystem, you don't need that. All you need is a way to connect with the node. It doesn't have to run on your computer. It can be any node anywhere. Pass the RPC URL, and then this particular Polkadot.js is going to automatically read every single function that exists on that particular substrate blockchain. And once you raise it, it's going to be giving you automatic type inference so that you don't make mistake. You're going to have access to every single function. you want to query them, you have queries, constant, and then the transactions, kind of like extrinsics. We call them extrinsic because that allows you to change the state of the substrate blockchain. And that is where this Polkadot.Js API works. There's also the contracts, which allows you to interact with an Ink Smart contract, the Ink Smart contract. Not just Ink Smart contracts, actually, pretty much contracts, any type of contract on Polkadot, even if it's Ask contract or Solang contract, this is how you interact with them. But this is a low-level tool, right? Because you have to be doing everything manually for the Ink contract. And that is why there's a library called the Use Inkaton that is developed by Aleph0, which is also a parachain on the Polkadot ecosystem. They've developed this Use Inkaton tool to be able to interact with your Ink Smart contract or any contract using from your React application. Under the hood, these guys, they're using the Polkadot API. If you check their package.json and you check the installed libraries, you can see Polkadot API contract, the keyring, all these are documented in this Polkadot.js application. So if you install this tool, it gives you access to a number of hooks. So it works just like what you would expect a React library to work like. It gives you some hooks, this using Katon. You can have the connect API, active chain, and all of these. And you can easily interact with your smart contract that is deployed on the Polkadot ecosystem. That is the work of the using Katon tool. And then on the server side, I mentioned you can also use the Polkadot.js and this Polkadot API library as well. You can create your own SDK off of these low-level tools and be able to use it in your Node.js application. And there's also the Rust-based server-side tool. It's also similar to Ethers, which is Subtxt. So if you go through the Subtxt tool, which is currently on GitHub right here, is a Rust-based crate. You see it's written purely in Rust that allows you to interact with substrate blockchains or even in smart contracts. You can interact with anything. You can submit expenses, you can subscribe to blogs, you can use it to read events. So like index your substrate blockchains. You can use it to index those events and store it to a database. All of that can be done using Subtxt. A very powerful tool that you also need to get familiar with if you're building in the Polkadot ecosystem. And last but not the least, we give us a list of some wallets that you can use to interact. We don't use MetaMask. We use wallets like Talisman, Subwallet, and Polkadot.js tool. This one, you can also call it a wallet, but in the real sense of it, it's not really a wallet, but it allows you to interact with a blockchain on the Polkadot ecosystem. So I think this is kind of like the last point for this our presentation right here. Sorry, I mean Subtxt tool. I'm gonna share the documentation as well, but it's Subtxt, not Subtxt. So it's not related to Subgraph. I see Abib asked a question. Subtxt, you can say it's related to Subgraph, but it has a lot more features. Subgraph is an indexing tool that allows you to index your smart contracts. But Subtxt is a tool that you can use to index blockchains. You can use it to interact with the blockchain, which is what Subgraph does not do. You can also use it to make calls to smart contracts or blockchain. You can use it to read the current state of the blockchain. But one thing that is very similar to Subgraph, and I'm actually very glad that you brought this up, and is very, very useful for the Polkadot ecosystem, is the Subsquid indexer. Subsquid is an indexer that supports substrate-based blockchains. If you go through their build, go through the documentation, you can see that it supports substrate-based indexing. 1 second. I'm trying to find the. No, let's just search. Let's just search for substrate. You can search for anything that you want on here. It has a substrate processor. Yeah, this is what I was looking for. That you can use to interact with, to index your substrate blockchain or even index your smart contract as well. So this is the equivalent of subgraph for Polkadot ecosystem chains. Very cool, very good question actually, very good observation. So with this last point, I think we've pretty much come to the end of this presentation. So I don't know, I'm still taking some questions. If you have any more questions, this is a very good time to ask about the questions. You can type it in the chat, or you can just unmute and ask any questions that you want.
So thank you very much. My own question is that, like what are the opportunities in this Polkadot ecosystem? And like from your own experience, which will you advise someone to keep on exploring the Ethereum ecosystem, like the L2s, or someone should just focus on this Polkadot? Because I'm trying to know the chain I want to be building on. That's just one of my questions.
Yeah, very good question, actually. Very good question. Sorry, the first part of the question, can you ask me the first part of the question again?
I want to know, like, what are the opportunities in this Polkadot ecosystem? I want to know the opportunities in it, and how can someone earn from this ecosystem?
Yeah, very good question, actually. Good question. So I mentioned, like in earlier when I was talking about the why Polkadot ecosystem. So Polkadot gives you access to a number of grants. You can see all those grants are listed right here. There's these grants, Web3 Foundation grants. If you build an application on the Polkadot ecosystem, you can submit for a grant, and then they can give you funding opportunities. And then there's also a lot of hackathons that are organized on Polkadot ecosystem. If you check for DoraHacks, if you check a lot of these hackathon platforms, even Encode Club, they organize at least 3 or 4 Polkadot-based hackathons per year. And all you need to do is be able to build with Ink or Substrate, and then you have access to all these guys. Sorry, I need to log in one more time. The Encode Club, let's see some of the programs. They have different Polkadot-based programs that you can see right here. Some of them, these are some of them. 4 weeks program. I think this is currently running, or it's going to be launching in early 2025. So they do like 3 or 4. I myself have been like a very consistent participant of the Encode Club hackathon. I think they do it like 3 times a year. So January time, they do another one in April, another one in May. And some of the last ones that I did, I'm not going to give figures, but they give like hackathons that go with like $10,000 in rewards, even $20,000 in rewards that are shared between participants that build interesting projects. And there's also a lot more hackathons right here. If you check the DoraHacks, you probably find a lot of hackathons that are related to Polkadot ecosystem. This is the Polkadot hackathon that's organized in Singapore that just ended. This is another one that was organized in Bangkok. So there's a lot of hackathons that are being organized to give people the experience and the opportunity to use the things that they've learned about Polkadot. And these are very good ways to earn. And also, one very key thing about Polkadot itself, which is not even related to hackathons or grants, is the fact that by contributing to Polkadot projects, you can actually become a Polkadot fellow member. And this gives you opportunity to earn salary just by contributing to open source projects on the Polkadot ecosystem. All you need to do is be able to relate to the Polkadot SDK or some of the Polkadot-based projects that are currently open source. So these are ways that you can earn money. And for the second part of the very great question, you wanted to know like if someone should actually stick to Ethereum and their tools or just focus on building on Polkadot. One thing that I would say is the blockchain world is a very big ecosystem, right? And just as we all know, there's a lot of blockchains, and we can't just push one single blockchain as the main one. But one thing that gives Polkadot an edge over every other blockchain is the fact that you can be on blockchain, on Polkadot right here, and you can interact with Ethereum blockchain. You can interact with Solana blockchain. You can interact with any other blockchain. So which means we all know currently, admittedly, Ethereum currently has like one of the largest market cap in terms of how many people are deploying projects on Ethereum. So if you decide that, oh, I don't want to use Ethereum, I want to use another blockchain, you have like a risk of actually missing out from all of that money. But we all know that Ethereum is also very expensive to build on because it's very slow. It has like a lot of issues with gas fees and all of that. That is why L2s are coming up. And even these L2s, the painful part about them is a lot of them are not interoperable. So you cannot easily be on Arbitrum and easily interoperate with Polygon. You have to rely on maybe bridges, like Chainlink bridges, or another thing that I know is Axelar, which is an interoperable network, but it's not even an Ethereum tool. It's something that is built on Cosmos. So it means if you're on Ethereum, you risk being stuck to a particular ecosystem. And if you want to bridge to another one, there's a very huge risk associated to bridges. So my advice would be a blockchain that allows you to interoperate on any network that you choose to deploy on, which is Polkadot. If you deploy your applications on Polkadot, you have a very good chance of benefiting from Polkadot and also benefiting from Ethereum. So you can build something that allows you to make use of the market cap of Ethereum, and then you are still on Polkadot managing every single thing on Polkadot because Polkadot is very fast. So my advice would be, because in the coming year, Polkadot has a vision to be what AWS is to Web2 ecosystem. And once this vision peaks, it's going to be like no catching up to Polkadot. There's literally going to be no catching up. You're going to be missing out hugely if you are not very well experienced on how to build on Polkadot and you don't have the skill set to be able to build on Polkadot. So that is kind of what I'm going to say. It's a very good decision to pick Polkadot as the blockchain of choice where you want to actually be building everything that you want to build upon.
All right. Thank you so much. So, does anyone have a question? If you have a question, you can still ask. You can either unmute or just send a message.
So yeah, I guess that concludes the end of our session. Of my talk. I don't know if the organizers have anything. I'll still be in the background. If you have any question, I'll still take them. But I think the meeting is done. We're pretty much like a couple of minutes over time. Thank you guys for staying to the end of the call and for your great questions, fantastic questions. If anybody still has any further questions, you can drop it on the channel. And I'm also a community member, so I'll go through them and provide answers to them if I see them. But I can't guarantee that the answers will come as soon as possible.
All right. Thank you very much, Mr. Bolaji Ahmed. Thank you. I had such a great time, and I'm sure others had too. And the questions were intriguing, were beautiful. So thank you very much. And those that joined us for the presentation too, thank you very, very, very much. All this would have been possible without you. So we appreciate you coming up and turning up for us. So yeah, I'll be dropping our socials, so you guys can just maybe follow up in case an exciting event like this comes up again, so you can easily see it from any of our socials. So I'll be dropping that. You should just check the chat. And also the materials Bolaji Ahmed dropped on the channel, I pinned everything. So you guys can just go on, just look at it. So whichever one you need to look at and everything you need to look at, I pinned them, so you can just go there and check it. So thank you very much. Thank you for your time. Thank you for coming.
Yeah, one more thing actually. We also have the second part of this session on Monday at the same time, where we're going to be going through an Ink Smart contract and going to be teaching how to interact with one and a walkthrough of what an Ink Smart contract looks like. So yeah, keep tuned with that. That's going to be a lot more fun than the theoretical part of this one is. So yeah, thank you guys.
Yeah, so like you said, now the fun continues, and right now it has to be on Monday. So please do well and join like you've done now, and also invite your friends, even your enemies, or even the friends of your enemies or the enemies of your friends. bring them over so they can also be part of this amazing presentation. So thank you. And like you said, if you have any question, you can just drop it in the channel. So when it says fit, when it's available, just respond to it. Thank you.